Hello, and welcome to my Delta printer project. My name is Randy, also known as the Old Man. Old man in a lot of ways, just now getting into 3D printing. I started with the Creality CR10, and that's been a good printer. It's not a high precision printer, but it works pretty well. So that's kind of got me into it. I started wanting to have a little more detail, just a little more, I guess would be the right thing to say. And so I started searching for what I might do for a new printer. And inevitably ended up with a Delta is what I wanted to do. It's not right for everybody, but for me it was. So I looked at printers like, as a starter, I thought about making the Neutron. If you go to ATOM's website, they have a project there for a 3D printer, a Delta printer, and I believe it's maybe an engraver, some other device, but it's a free project so that you can download the entire design and print, providing you have a 3D printer, most of the Neutron's parts, I think all of them actually, and then you'll just be able to assemble it. Obviously you'll have to buy a controller and some motors and things like that, but you can get started with a very low cost Delta printer. So I thought about that, and I thought, well, that's just not for me. I don't want to start with something that small and imprecise. I'm trying to get more precision. So I looked at a number of other printers, including Adams 2.5, and that was the closest thing I thought that might work for me. But inevitably in my search, I ran across a printer or a project for another gentleman named Werner Berry. Now, this gentleman is truly amazing, at least in my book. You could say that his printer, which he built from scratch, and he's very fortunate to have the equipment to make a lot of these pieces, but it's just so impressive to me to see the things that he has done that I guess you could call it a little bit of hero worship, or I idol the guy, but it's just very, very amazing to me that he started out with pretty much nothing and took it all the way home. It's an excellent printer, and I'll post at the bottom of this, I'll post the link for Werner's site. He's very supportive of the industry, and inevitably because of it, he now has an online presence where you can purchase a lot of the parts that went into the Berry Bot, and excellent, excellent hardware. Just can't say enough good things about it. So I in turn wanted a Berry Bot and couldn't have one because they literally aren't for sale. So I started looking for ways to go about producing my Delta printer and come out with the same quality that Werner came up with. This video will revolve completely around my take on Werner Berry's printer and the best I can make it with the limited resources I have. And I know a lot of you won't have full metal shops to work with, so hopefully this will give you some idea how you can get there. I've watched a lot of videos, and a lot of these videos do nothing except kind of show you the start and run through bolting the thing together in very high speed. I'm not going to do that. What I'm going to do is I'm going to show you the parts. I'm going to show you how each part goes together, and then I'm going to show you the assembly after it's done. What I'm going to try and show you here is the base of my printer. My printer is basically going to be about a 550-ish millimeter across the base, because I'm using 500 millimeter Open Linear or Linear Rail from OpenBuildStore.PartStore.com, and it just made it easier for me not to cut them down. Also, I wanted a bigger printer, and you'll see some of that as we go along. But I want to start by talking about the pieces, just a few of the pieces you have to consider when you're building this, and that is some of the plastic parts that you have to assemble or have to print or have printed. If you don't have a printer now, you might know somebody that does and could print some of the parts for you. Some of the more precision things like good stepper motors. One of the most important things in my book is the electronics. The electronics, because I come from an electronic background, and the power behind any machine is what limits the machine. So again, since Warner Barry recommended the Duet product, which I can also provide a link to, since his initial purchase, they have come out with newer versions. This is a 32-bit Duet, and we'll talk a lot more about that when we get to that part of the project. But just things like the electronics, the motors, the fans, good quality fans so that you don't have bearings that rattle, the plastic parts, the hardware. Prepare to spend, I have no idea how much money I've spent in metric hardware, which is damn near impossible to buy at any local store here in the States. It's all special order. So I've been using McMaster-Carr. They're an excellent supply, and they're very quick to ship. So let's talk about a few of these parts. And I'm going to, I don't know that you can see this very well, but I'll probably zoom in on each one so that you can see them as we go along. The this particular set of plastics that were designed and put on Thingiverse. If you don't know about Thingiverse, you should look it up right away, by a fellow named William F. Cook, based out of Maryland, I believe. But he designed a set of corner pieces for a Delta printer, both top, notice a little thinner, and bottom. And those corner pieces are what he refers to as the Cozell Max. And you may be aware with the Cozell printer line, that printer line has been around for a long time. It's probably one of the lesser expensive generic kits for Deltas, and seems to work reasonably well. But I was looking for something very heavy duty, and that gave me some flexibility. I printed these in green, not that I'm going to be using green, I'm going to be using black. I printed them in green just so they would show up well and you could see them. The sides, well, here we go. So the sides are 60 millimeters by 20 millimeters. So you can either use, and I'm guessing they designed it that way, two 20 millimeter by 20 millimeter stock to run across, so between the two or the three endpoints. I'm not really going that route. I'm going by a 20 by 60 millimeter, so one large plate that runs all the way across there to try and give myself a little more stability. Something else that I loved about it that I was looking for is a 20 by 40 upright. Again, trying to get something a little more stable going up, to provide make the whole thing a little more rigid. Some people can build their own, but I'm stuck with having to use readily available linear rail. So that's kind of how it goes. But it's very well made. It even has the name Max on the end here, and but he did a really good job. So how this end piece works, the motor, this is the motor mount, and the motor mounts into the motor mount like such, and then the motor mount, whole thing assembles like that. So you have the initial screws let me put this here. These initial sides, boy, I'm terrible at this, aren't I? These initial side screws are what go into the frame to hold it in place. Additionally, you have these two screws that go through the motor mount, and then you have two more from the motor mount. So there's a lot of plastic going down the side of that 20x60 to give you a lot of stability. And I think that's just the perfect way to go. Each one of these sets probably takes, I want to say, maybe couple of 3 hours to print, something like that. It wasn't terrible. And then I used support material. So the support material has to be cleaned out of all the holes, and there are a lot of holes. So it's not that big a job. It just depends on how good your printer does, but mine did a really good job and it worked out very well. So I'm happy with that. Now this is the top. This is basically the same as the bottom, just a little bit thinner, a little bit longer, and it is specifically designed for 20x20 rail, and that works out great. The difference here that I find is his design, and I'm calling it his design because I have not seen it anywhere else. It's probably around, but Mr. Cook's design has a belt tensioner that I liked a lot, and that's this little piece right here. This belt tensioner, most of the Cosel designs I've seen, the belt or the idler pulley for the belt, which would mount right in here, and it would be very simple. The tension would be required to be taken up somewhere else in the belt. Using this device, it sits in here, so you can see this end is part of the linear rail, and you can see the linear rail in here. So they match up so that this rides, the belt tensioner rides on the linear rail just like the top piece does. The next part of it is there is a screw hole that goes here, and it goes through, and that just holds this and gives us some up and down slack so that you can adjust it up and down. There's also a 4mm screw hole here that allows you to put a long, I'm using about a 40mm screw to go down through here into this, and hopefully I'll get a close-up of it, but there's a slot to put a thin nut inside here, so the 40mm is in the belt. Using this device, it sits in here, so you can see this end is part of the linear rail, and you can see the linear rail in here. So they match up so that this rides, the belt tensioner rides on the linear rail just like the top piece does. The next part of it is there is a screw hole that goes here, and it goes through, and that just holds this and gives us some up and down slack so that you can adjust it up and down. There's also a 4mm screw hole here that allows you to put a long, I'm using about a 40mm screw to go down through here into this, and hopefully I'll get a close-up of it, but there's a slot to put a thin nut inside here, so the 40mm screw goes in the nut, and that just simply allows this piece to go up and down. So you start with it down, and as you need to tension the belt, you start pulling it up, pulling it up. Now obviously it can't go any lower than where this screw hole here is, because that's the end stop. But overall it's going to give you a good 10 mils, maybe closer to 15, to tension the belt up and down. Also, the idler pulley will go in here, and a 3mm screw will go through here to the idler pulley, which sits in these little divots, and that's about all there is to it. It's a simple and elegant design. I like it a lot, and it gives you some way to tension other than using basically like what I refer to as clothespin springs. I don't know where that idea come from. I'm sure they work, but I don't like it. So, and that's just my personal opinion. So I'm going to be building the base, and I'll show you that as we go along, but I do want to show you what it kind of looks like when it's done, and that would be this. Now, the motors aren't installed here because this was just basically as a template, but you can see the black Max end pieces, the motor mounts, and so on and so forth. I put this together because I needed to build a metal plate to mount things to on the inside. So what I did was I somewhat assembled this so I could then design the cover plate. And I'm lucky enough to have access to a large size plotter, and I was able to make my measurements, make the design. And for those of you who have never done a metal work, which unfortunately I don't have access to machines, I have done some metal work. I wouldn't say I'm great at it, but I've done it. There's a company called E-Machine Shop. It's an online service, and they provide free CAD software. Use the term CAD loosely, but it's good software for what it is. And I can design plates and things on it, and you can basically have any number that you want to make made by them. It's not inexpensive, especially for small runs. I mean, they're basically a prototyping kind of house or small run facility. And I've had these plates, this first plate, I'm having them build this plate, and I'm having them build the platen. As I said, it's not inexpensive, but these plates are back, and I'll be affixing all the controller board, the power supply, and everything will be mounted to this plate. And I'll just give you a quick preview of what that plate looks like, because we'll be talking about it more later. This is the plate, one of the plates I had made. I had a few made, but fan grills here, hole for the wire to come up for the heated bed, and of course all the holes and things to mount it down and mount the power supplies and mount the controller are here. So this is a steel plate, so it's very rigid, and that's what I was looking for, something very durable and very rigid, because the platen will be suspended off of this. So we'll get to that more as we get along to it. But for now, I'm just going to go ahead and put together the base assembly. So I'll show you that, and we'll talk about it when it's done. Thank you.